Have you ever looked at a long division problem and thought there has to be a better way? Well, there is. Today I am going to teach you a Vedic maths method. I call it green math, that is so elegant you will think it's a magic trick, but it's all logic. This technique is called the crowning gem of Vedic maths. This technique, it allows you to do large division with large numbers in one single line. No long division columns, no stress, and definitely no confusion. Let's do this. 209 divided by 52. This means we want to see how many 52s are there in 209. We write it like this. Let me show you first what's happening here. Now, we have 50 here and we have 2 here. So let's divide the first two digits, this 20 by 5. 5 goes 4 into 20, right? So we take 4 50s from 209. 450 is 200 and we are left with 9. Then we also take 4 2s, that is 8, from 9 and we are left with the remainder 1. So it means our answer is 4 remainder 1. Now we can show this in division form in one line. We write 209 like that. Here we put a vertical line to separate the answer from the remainder. Here we'll have the answer, here we'll have the remainder. Now write this 52 like this. 2 is flagged. And first we'll always divide by this 5, the first digit on the left. 20 divided by 5 is 5 into 20 goes 4 remainder 0. And then we have to take 4 2s also. So we'll multiply. The next step is we multiply this answer digit 4 by this flagged number 2. 4 times 2 is 8 and we subtract it from this 9. So 8 from 9 is 1 and that is our remainder. Exactly same thing that we did here. We have the answer here 4 remainder 1. And 321 divided by 6 is done the same way. We put a vertical line here after one digit from right for the remainder and write 63 here, 6 here and 3 in the 3 is flagged. Now 32 divided by 6 is 6 times 5 is 30 and 2 remainder, right? And then the next step is this answer digit times this flagged number. 5 times 3 is 15 and we take that 15 from this 21 to get the remainder 6. What we did is we subtracted 5 60s actually from 321. So we subtracted 300 and we are left with 21. Then we subtracted 5 3s, that is 15, from this 21. That is what's happening in the back end. Actually we subtracted as a whole, we subtracted 5 60s and then 5 3s, that is 15. So we subtracted 5 63s and the remainder is 6 and that's our answer. If we divide 10 by 3, we can directly see that it's equal to 3 remainder 1, right? But What if we see the other possibilities? 10 divided by 3 can be 3 times 2 is 6 and we have remainder 4. Or 10 divided by 3 is 3 times 1 is 3 and remainder 7, right? Or let's go do a little further. 0, remainder 10, right? But all of these are correct actually. Or let's go a little crazy with that. Let's say 3 times 4 is 12, right? So remainder, when we do 10 minus 12, it's bar 2, right? So whichever we want at some type of division, we can use that. Before we have been using this always, but we can use this or this whenever we need to. So let's see what happens here when we have 503 divided by 7. So we set it like before, like we did in the last lesson. Exactly same thing we are doing, and we put a vertical line here after one digit from the right for the remainder, and 7 will write like that as before, 2 on the flag. Now, like the previous lesson, 50 divided by 7 is 7 times 7 is 49, and we have remainder 3. Sorry, remainder 1. So we have 13 here. Now next step is we multiply this 7, the answer digit, new answer digit, by the number on the flag. 7 times 2 is 14. And when we do 13 minus 14, we have the remainder bar 1. And we don't want that. Or now to solve this, we have two options. One, we can see that this 7 is actually 772s, right? We have 772s. So we bring 172 here, make it 6, and when we bring 72 here, it's 72 with added with bar 1, means 72 minus 1 is 71. So 6 remainder 71 will be our answer. Another way of doing this is avoiding the bar number in the remainder is we look ahead of time and see if the division is possible, subtraction is possible. If it is not, we can. So we have 72 here like before. Now 50 divided by 7 is 7 times 7 is 49, and we'll have remainder 1. And in the next step, if we see in our mind, we don't write 7 here, I'm just showing you. In our mind, if we see this one and we see 7 times 2 is 14 and 13 minus 14 will give us negative number, we write 6 here instead of 7. And remember that when we write 6 here, 7 times 6 is what? 7 times 6 is 42. So we have 8 remainder here, more than 7, but doesn't matter. We have 83 here, and when we do the next step, 6 times 2 is 12. 83 minus 12 will give us 71, and that's the exact same answer here. And we were able to avoid the negative number here by looking ahead of time. Just like we learned, it's just the long number, but the process is same. We'll write 1, 7, 4, 9, 6 like this. and we have now, let's set this up like before, and here we have this vertical line for the remainder. And we write 72 like this. Now, like before, we divide this 1 is less than 7, so we divide 17 by 7. So it's 7 times 2 is 14, and we have a remainder 3. Now, look at this diagonal. When the diagonal is complete, it means our one cycle is complete. Now, after this, it's always multiply, subtract, divide, multiply, subtract, divide. That's the cycle. So let me write it here. After dividing with this number once, then we have to multiply, subtract, and divide. When we complete the last step, divide, we'll see that the diagonal is complete, right? Now here we have these 2, 3 and 4 in diagonal. Next step is we multiply, that is the new digit of the answer, times this flag number. 2 times 2 is 4, and we subtract that 4 from this 34. So we have subtraction to get 30, and that is our new divisor. So 30 divided by 7 will give us 4, remainder 2. Now again our diagonal is complete. It means our cycle is complete. And after that we keep going till we reach the remainder. Now we'll do multiply 4 times this 2 is 8, and this 29 minus 8 is 21, and now 21 divided by this 7 is 3, remainder 0, and our diagonal is complete. Then now in the end, just multiply and subtract, you will get your remainder. So in the end, the last step is multiply and subtract, right? So we multiply 3 by 2, 3 times 2 is 6, and this 6 minus 6 is 0, so we have remainder 0. It means that's our answer, 243. Now this cycle can be repeated forever, so we can decimalize the remainder. 40342. Let's write it in this way: 40342, and I'll put point here. 1, 2, 3, 4, 5, 6. Let's go to the 6 decimal places. And like we did before in the previous lessons, we'll set it up like this. And then we write the 73 like this, 7 here and 3 on the flag. Okay. And remember, the decimal point in the answer will be where we used to put this vertical line before the remainder. 1 decimal place to the left from here. So here will be the decimal point in the answer always. Okay. So 4 is less than 7. So 40 divided by 7 is, 7 goes into 40, 7 times 5 is 35. And we have 5 remainder, right? Now our diagonal is complete. This cycle will start from here. So first we multiply this digit, new digit of the answer, by the flag number. 5 times 3 is 15. Then we subtract. So 53 minus 15 will give us 38, and 38 divided by 7 will be 7 times 5 is 35, and we have 3 remainder. Then our diagonal is complete now. So we'll multiply again the new digit of the answer by the flag number. 5 times 3 is 15 and 34 minus 15 is 29, 19. So 19 divided by 7 will be 7 times 2 is 14 and we have 5 remainder. Right? Now, next is 2 times this 3. 2 times 3 is 6 and we subtract 6 from this 52. 52 minus 6 is 46 and 7 times 46 divided by 7 is 7 times 6 is 42 and we have 4 remainder. Like that we can keep going and we'll get digits after the decimal point. So now again the cycle is complete. 6 times 3 is 18. 40 minus 18 is 22 and 22 divided by this 7 is 3, remainder 1, right? And in the next step, 3 times 3 is 9. This 10 minus 9 is 1. So 1 divided by 7 is 0, remainder 1. Now we have 0 times 3, that is 0. This 10 minus 0 is still 10 and 10 divided by this 7 will be 1, remainder 3. Next is 1 times 3 is 3. 30 minus 3 is 27 and 27 divided by 7 is 7 times 3 is 21 and 6 remainder. Now again let's do 2 more. 3 times 3 is 9 and 60 minus 9 is 51. 51 divided by this 7 is 7, remainder 2, because 7 times 7 is 49 and we have 2 left. Now we have 6 digits. So like that we can keep going. We can keep repeating this cycle and we'll get decimal places. Now here is the question. Find 23.1 divided by 83 to 3 decimal places. So let's do that. Let's write 23.1 like that and let's put 2 more zeros. And we have this line here and we have this line here. And we write 83 like this. Okay, let's start again. And as I told you before, the one space on the left of the decimal point, we used to put a vertical line for separating the whole number and the remainder in the answer. So exactly at that same place, we'll put the decimal point in the answer. Okay, so 2 divided by, on the left side of the decimal point, 2 divided by 8 is 0, remainder 2. Now we have 23 here and the next step will be, we start repeating this cycle. So 0 times 3 is 0, 23 minus 0 is still 23. And when we divide 23 by 8, we have 8 times 2 is 16 and we have 7 remainder. Okay, now again multiply 2 by this 3. We have 2 times 3 is 6. 71 minus 6 is 65. And when we do 65 divided by 8, we have 8 remainder 1. 8 times 8 is 64 and we have 1 remainder. But the moment you put 1 here, we can see that the next step will give us negative number. This 10 minus 8 times 3 is 24. 10 minus 24 will give us negative number. So instead of putting 8 remainder 1, let's put 7 here, 1 less. So we were dividing, remember we were dividing 65 by 8 and we said 8 remainder 1. So if we do 65 by 8 and we write it 7 here, 8 times 7 is 56. So 65 and 56, there is 9 remainder. 1 more than 8, but doesn't matter. And 90 minus 7 times 3 is 21. Now it's 69, and 69 divided by 8 is 8 times 8 is 64, and we have 69, and 8 times 8 is 64, and we have 5 remainder. Now we already have 3 digits, and the question says find the this answer to 3 decimal places. That's our answer. When we divide 97 by 28, we can see that, let's do it here, 90, 28 like this. Now, when the flag number is large here, again and again we have to reduce the answer digit by 1, remember? So if I put a line, vertical line here for remainder, we can see 9 divided by 2 is 2 times 4 is 8 and remainder 1. But in the next step, we can see 17 minus 8 times 4 is 32. 17 minus 32 will give us negative number. So we reduce this 4 to 3, and we say 3 times 8 is 2 times 3 is 6 and remainder 3. Now we have 37 here. 24 will give us 13. And our remainder is 13. Now, when the flag number is large, we have to do this again and again. But we can avoid this. How? Let's see. Here I'll write 97 as before. But instead of writing 28 in the as a divisor, we'll write 28 as the bar number, that is 3 bar 2, and you know how to convert it. Now we have small number in the flag. It is a bar number, but it is small. So let's see how to use that. Exactly at same place we'll put this bar, this vertical line, and 9 divided by 3 now is 3 times 3 is 9 and remainder 0. Now we have to do this 7 minus 3 times bar 2 is bar 6, right? So 7 minus bar 6. When we are bar 6 means negative 6. When we are subtracting a negative number, actually we are adding them, and this minus sign and this minus sign, two negatives make positive. So 7 plus 6 actually we have to do, and we have the same result, same answer as before. And there is a shortcut here, that whenever we have bar number, instead of subtracting like in this method, we have to add, right? So let's do exactly same thing here. Let's do the first 3 digits of this answer, just to know the method. 3 divided by, so let's say we are decimalizing it too. So I'm interested in first 3 digits, and our answer choice will have a point here. And we are converting 77 is big digits. We are converting it to bar number. It will be 8 bar 3, right? So we'll write 8 bar 3 like this. And now 3 is less than 8, and 33 divided by 8 is 8 times 4 is 32 and remainder 1. Now we have 4 times bar 3 is bar 12, and 13 plus 12 is 25. In the next step, 25 divided by 8 is 8 times 3 is 24 and 1 remainder. Again, we have 3 times bar 3 is bar 9, and 13 plus 9 is 22, and 22 divided by 22 divided by 8 is 8 times 2 is 16, and we have 6 remainder, and so on. So we have done 3 digits here, and we can use these bar numbers to avoid that reducing 1 digit of the answer when the flag digit is large. You have unlocked one of the smartest division techniques in green math, and it already feels that it's a superpower, right? But what happens when we combine multiple techniques together? In the next video, I will show you how to build an actual problem solving routine, a mental framework that your child can use to solve any math problem faster and with confidence. So that is the place, that is where green math stops being just bunch of tricks and starts being becomes a true thinking system. See you in the next one.